Hi, my name is Lixin Chen. I'm doing this video for the theory application. Today, I'm going to talk about linear search versus binary search. Today, we're going to talk about linear search versus binary search. Let's start with a simple example. Now we have an array containing 10 digits. If you want to solve a question like, is 24 in this array? Or what is the position of 24 in this array? Traditionally, we can use linear search. What linear search do is to compare every digit in this array from start to the end, one by one, until it finds the target number. If we have the n element in this array, the order notation of linear search is order of n. Therefore, if n is very big, this algorithm is slow because we have to loop through the array. So, how to make it faster? Here comes the binary search. The difference here is that we need the data to be sorted to do the binary search. You will understand the reason behind this once you see the whole process. The basic idea of binary search is to narrow down the search space of the target number. To begin with, we say the search space is the whole array, and we use two pointers to show this. You can call them left and right, or start and end. Since we know the position of each digit, in this case the position of start is 0 and end is 9. Therefore, the midpoint of them is 4. Then we compare the value of this midpoint to our target number. We found that 24 is bigger than 16, so we know that the 24 must be in the right half of this range, because the data is sorted. So we reset our start pointer to position of 5, which is 1 after the midpoint. Then we do the same thing again as above with updated start and end. This time, the target number is smaller than the midpoint, so the target must be in the left half of the range. So we reset our end to mid minus 1, and do the same thing again until we find our target number. All the start pointers access the end pointers. So how fast is this algorithm? Let's imagine that we have search space of n elements. With one simple comparison, we cut our search space down to n over 2. Then with one more comparison, we cut it down to n over 4. And then half and half again until we got only 1. So how many total operations in the very worst case will we have to run until we figure out if it contains an element or not? In other words, how many times can we divide n by 2 until we get down to just 1? So this is what log of n expressed with the basis of 2. So now we know that the order notation of binary search is log of n, which is faster than the linear search. So let's now look at some implementation of binary search. So the question is find any position of the target number in a sorted array. Return -1 if target does not exist. We can write our binary search algorithm recursively or iteratively. Just as we mentioned above, if the start position accesses the end position, the search is over. Otherwise, we compute the midpoint of starting end and compare its value to our target number. If the value of the midpoint equals to the target number, return that position of that midpoint, or narrow down the search space and repeat the process. Well, thanks for watching and Happy New Year!